Welcome to True Projects. In this video, we are going to explain about the project, which is Monkeypox diagnosis with interpretable deep learning. Introduction of the project. Monkeypox is a viral disease primarily found in monkeys, but it can affect humans, causing symptoms similar to chickenpox, smallpox, measles, with potential complications like sepsis and pneumonia. The disease has been spreading slowly and had reached 29 countries with over 1,000 confirmed cases by June 2022. And there is no specific treatment for it, making vaccination a crucial preventive measure. Traditional diagnostic methods like PCR testing have limitations, and the cost of test kits can be prohibitive, especially in the event of global pandemic. The project proposes to improve monkeypox diagnosis by developing and testing 6 deep learning models using transfer learning, implementing generalization and regularization techniques, and providing interpretability with the goal of automating disease diagnosis, especially in regions with limited healthcare access. Deep learning significance lies in its capacity to automate tasks, discern intricate patterns, provide accurate predictions, and facilitate personalized solutions across diverse fields from healthcare to autonomous systems. Objective of the project. The project aims to develop a deep learning model for diagnosing monkeypox disease by utilizing transfer learning techniques which involve leveraging pre-trained models to enhance the accuracy and effectiveness of diagnostic process. It seeks to evaluate the diagnostic performance of 6 different deep learning models, namely VGG16, ResNet50, MobileNet V2 and VGG19, in order to identify the most suitable model for precise monkeypox disease diagnosis. The project's objective is to calculate and compare the accuracy rates of modified versions of VGG19 and MobileNet V2 models to ascertain which model configuration delivers the highest accuracy in diagnosing monkeypox. The primary goal is to develop an automated system for monkeypox diagnosis that offers a rapid and dependable method for early disease detection with a specific focus on regions with limited access to healthcare. To implement this project, we need hardware and software requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies like HTML, CSS, JavaScript, and Bootstrap 4. In hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this initial step, essential Python libraries are imported to facilitate various tasks throughout the project. These packages include NumPy, Pandas, Seaborn, Matplotlib for data handling and visualization, TensorFlow for deep learning, and sklearn for machine learning functionalities. The next step is exploring the dataset. The project starts by examining the monkeypox dataset, which likely includes augmented images. This step involves understanding the structure, content, and characteristics of the dataset, which is essential for subsequent data processing and model development. The next step is image processing. In this step, images are read and resized to a consistent size, and then they are stored with the features as X while extracting and encoding corresponding labels as Y. The processed image data is then saved to avoid recomputation in the future. The next step is pre-processing images. To prepare the data, which is image data for machine learning or deep learning, several pre-processing steps are performed. First, the pixel values are normalized, usually scaled to a range between 0 and 1 to ensure uniformity and facilitate model training. Additionally, the order of the images is randomized to avoid any bias. Finally, labels are one-hot encoded, a common technique for representing categorical data, making it suitable for machine learning models. The next step is splitting the data into train and test. The dataset is divided into 2 sets, a training set and a testing set. This division is crucial for assessing the model's performance. The next step is building the model. In this step, the models are built, which are machine learning and deep learning models. The next step is model training. The model is trained using the training data. During training, the models learn to identify patterns in the data so that it can make accurate predictions later. The next step is Flask framework with SQLite for sign-up and sign-in. Flask, a lightweight Python web framework, is employed to create a web application. The application includes features for user sign-up and sign-in, Additionally, a SQLite database is often used for managing user accounts. The next step is user gives input as feature values. Coming to the next step, which is the given input is preprocessed for prediction. When a user interacts with the web application and provides input, these inputs need to be preprocessed to ensure compatibility with the trained model. This may involve data validation, scaling, or any other necessary transformations. The next step is trained model is used for prediction. Finally, the trained model is used to make predictions based on the user input the models provide on output, which is then presented to user through the web application. This enables users to receive predictions or insights based on the trained model's capabilities. Algorithms which are used in this project are VGG16. It is a convolutional neural network architecture. It consists of 16 weight layers, including 13 convolutional layers and 3 fully connected layers. It is used in this project for its effectiveness in image recognition tasks. It is a well-established and powerful model for image classification, making it suitable for diagnosing monkeypox based on image data. The next algorithm is ResNet50, which is Residual Network 50. It is another CNN architecture known for its depth. It has 50 weight layers and it's characterized by residual blocks that help in mitigating vanishing gradient problem. It is employed due to its deep architecture and ability to capture intricate features in images. It can excel in complex image classification tasks like monkeypox diagnosis. Coming to the next algorithm, which is VGG19, Visual Geometry Group of 19. It is an extension of VGG16 with 19 weight layers, including 16 convolutional layers and 3 fully connected layers. It maintains the simplicity and effectiveness of VGG16. It is used as an alternative to VGG16, offering similar capabilities with a slightly deeper architecture. It helps exploring whether the additional layer provides improved monkeypox diagnosis performance. The next algorithm is MobileNet V2. It is a lightweight CNN architecture designed for mobile and embedded applications. It is known for its efficiency and small model size, making it suitable for devices with limited computational resources. It is incorporated in this project to assess its efficiency in monkeypox diagnosis. Its small model size allows for faster inference, making it suitable for resource-constrained environments such as project potential use in regions with limited healthcare access. As an extension, we applied hybrid model to produce a more robust and accurate result, and it is used for final prediction, and we built front-end using Flask framework for user testing with user authentication. We have assessed the performance of multiple deep learning models for monkeypox diagnosis. This evaluation is crucial for understanding how each model performs in real-world scenarios. We have evaluated those using accuracy, precision, recall, and FN score. So here we have accuracy score graph, where x-axis represents accuracy score of each algorithm, and on y-axis we have algorithm names. Accuracy is the proportion of correct predictions in a classification task, measuring the overall correctness of a model prediction. So here we have precision score comparison graph, where x-axis represents precision score of each algorithm, and on y-axis we have algorithm names. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here we have recall comparison graph, where x-axis represents recall score, and it is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring model's ability to capture all relevant instances without missing any. Here we have FN score comparison graph. On x-axis we have FN score for each algorithm, and on y-axis we have algorithm names. FN score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. For execution of the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. Here we have model files. These files contain the algorithm information which will be loaded into project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Here we have signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I am copying the path. Now we need to open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. So here we can see that current directory is changed to the code folders directory, which is code folders path. Here we need to type the command which is python space app.py and click on enter. This will compile app.py file using the command python app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost, this is the localhost, and the port, unless configured differently. Now we need to copy this path and paste it in any web browser. So I am copying the path. I prefer Google Chrome, so I'll paste it in that. So here we need to paste the link and now we need to click on enter. So here we can see that web page of the project is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a link which is logon link. First we need to click on it and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to enter credentials so that we can log in. So I'm giving my username and the password. And now we need to click on sign in. We have signed in successfully. Here, by clicking on the choose file button, we need to upload the disease images. So I'm clicking on choose file button. I'm selecting the first image and clicking on open. And now we need to click on upload. So here we can see that in the blue color text, it is predicted as monkeypox detected, which means the person is suffering from monkeypox. Now we will upload one more image. This time I'm selecting the second image. So here we can see that it is predicted that it is non-monkeypox. Now we will upload one more image and see what will be predicted. I'm selecting the fifth image and now we will click on open. So here in the blue color text we can see that it is predicted as monkeypox detected. In this way we can upload the diseases images so that the system will predict whether it is monkeypox or not. Now we will log out. Conclusion of the project. The project assessment of deep learning models including VGG19, VGG16, ResNet 50 and MobileNet V2 demonstrates that transfer learning techniques can significantly enhance the accuracy of monkeypox disease diagnosis. Through the rigorous evaluation, the project identifies that most accurate model configuration, specifically the modified versions of VGG19 and MobileNet V2, which prove to be the most suitable for precise monkeypox diagnosis. The development of an automated monkeypox diagnosis system addresses the critical need for quick and reliable early detection, especially in regions with limited access to healthcare, potentially improving patient outcomes. The deep learning models and automated diagnostic systems established in the project have broader implications for the field of medical diagnostics, showing the potential for using similar techniques in the diagnosis of other diseases with visual symptoms. By providing an accessible and accurate diagnostic tool, this project contributes to the goal of making healthcare more widely available, particularly in underserved areas, and underscores the value of deep learning in improving disease detection and patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, Please visit True Project's YouTube channel and subscribe.